Okay, so sequences versus series and summation notation. When the terms of a sequence are added, the resulting expression is a series. A series can be finite or it could be infinite. Finite sequence. That's 3, 6, 9, and 12. That becomes a series when you add those terms instead. So 3 plus 6 plus 9 plus 12 plus 15. An infinite sequence, would be that same thing except the dot dot dot. It means it goes on forever and ever and ever. So there's no end to that. And then you would be able to add those as well. Probably more so in calculus, but these are the ones that we'll be dealing with more so in this class. So infinite, finite, sequence versus series. Now we're talking about series. You can use summation notation to write a series. For example, for the finite series shown above, that's this one right here, you can write this. So this is the expression that you could use, except it stops a little bit sooner. This 1 down here means to start counting at 1. Usually it'll say n equals 1. That means start when n equals 1. And then the top is going to tell you where to stop. Stop adding at the third term. So they want you to start at the first term and stop at the third term. This expanded out, so this is kind of like a shorthand type of a thing. What this symbolizes is to add the first term when I plug in 1 plus the second term, because you're not going to skip around, which would be 2, plus 2 to the n to the 3. I'm not going to do another one because it tells me to stop there. And then if you were to add these up, you would get 14. This is summation notation. It represents this series expanded out. I should have 1, 2, 3 terms, the first to the third. Okay, let's try an example. Thank you for your patience there. An arithmetic series is an expression formed by adding the terms of an arithmetic sequence, which is what we've been talking about. And the sum, so we know summation notation from just a minute ago, but the sum can be found using this formula. The sum of n terms, so the first to the nth, is n, which represents the number of terms, over 2 times a sub 1 plus a sub n. Memorize this formula. It's super duper important. Memorize it. So we know first term, we know nth term. N is the number of terms. So let's try it. For example, find the sum of this series. 17 plus 25 plus 33 dot 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 all the way to 65. So my first term, a sub 1, is 17. My last term is a sub n. Well, what do I want? I want to find the sum of this. So how do I do that? Well, let's plug in everything that we know so that we can find some things. Well, let's see. Do I have everything that I need in order to go in here? I want the sum of some number of terms, but I don't know how many there are. I need the n for this one. I have the first term, I have the last term, but I don't know how many terms there are all the way from here to here. I could keep adding and adding and adding because I know what the common difference is, but if you get a really high number there, that is not going to be effective. So our goal is going to be to find this n. Well, how do we do that? Good question, and I'm glad that you asked. You have the formula that we used yesterday, or in our last lesson, which was a sub n equals a sub 1 plus n minus 1 times d. Well, a sub n for this one is 65 equals a sub 1, the first term is 17, plus n, that's what I'm trying to find, minus 1 times d. What's the d here? What's the difference? Well, 17 plus 8 gives me 25, plus 8 gives me 33. So my common difference is 8. So I have 65 equals 17. Go ahead and distribute. Plus 8n minus 8. 65 equals 8n plus 9. Then you're going to subtract 9 from both sides. I'm trying to do the math in my head, but I'm struggling to do it in my head. So 65 minus 9 is a number. I'm going to have to use my calculator. It's 56. So then n is equal to 7. Delightful. Now I have everything that I need. I can now plug into this formula that we have here. So the sum of 7 terms is equal to 7 over 2 times the first term, which is 17, plus the last term, which is 65. It's basically like finding the average, but then you're multiplying by how many terms there are. So the sum of the 7 terms is 7 over 2 times 82, and when I multiply 7 times 82 and divide by 2, I get 287. So the sum of the first 7 terms is 287. Very good. Now, for the next one, find the sum of this series. Find the sum of this series. Well, it is arithmetic, and I can tell that it's arithmetic because it's just 5 times a variable, so it's just a variable times this plus 3. Another way to tell you, just a little bit extra information, it's like if this was y equals 5x plus 3. And if you were to graph this, you would get a line. So everything that just has the variable to the first term only, and there's no fractions here, no decimals, nothing weird with the variable, it's not in the denominator or anything, then it's going to be arithmetic pretty much always. If you look at all of the equations you just have some number times a variable plus or minus something else. So what do I want? I want to find the sum of this. Well, this is great, but I also know that I can do this 2 ways. Way number 1 would be start counting at the second term, so 5 times 2 plus 3. That's the first thing I need to add. That's the first term when I plug in 2. Plus 5 times 3 plus 3. Plus 5 times 4 plus 3. When do I stop? When I run out of space? No, at the 5th one. So 5 times 5 plus 3. You can see me. Sorry about that. There you go. So I could do that, and I could add them all up, and I could get, once I simplified, I have 13 plus 18 plus 23 plus 28, simplifying each of these, and I would get 82. That, however, can be long, because if this doesn't just go from 2 to 5, but let's say it goes from 2 to 10 instead, then you don't want to expand this out because it's going to eat up all your test time especially. So your other way is to use that formula. The sum of, well, how many terms are there from 2 to 5? 1, 2, 3, 4. There's 4 terms because they're the second, third, fourth, second, third, fourth, fifth term. So there's 4 terms. Equals n over 2, so 4 over 2, times the first term, so when you plug in 2 to here, you get 13, plus the last term, when you plug in 5 into here, 5 times 5, 25 plus 3, we learned it from here, is 28, and then you're still going to get the same answer, 82. Either one of these work. I'm going to tell you though, it's better to use a formula because if you have a lot of terms, like if you just have a couple, 2, 3 terms, no one really cares. But if you have more than 3 or 4, you definitely want to use just this formula instead. So I've shown you 2 different ways. You can take your pick, but I would pick this one pretty much every time. Also, it kind of reinforces the summation, the sum formula that you learned right here. Okay, so that's 2 different topics. We have series and sequences, 2 formulas that you want to make sure that you know really, really well. Thank you for joining me today.